Hello everyone, I'm Laurentius Kuncoro Prabhu Saputra. In this video, I want to share you about how to do pneumatic simulation using Festo Fluid Sim application or program in your laptop. Okay, for this scenario, we we have uh, we have the scenario like this. The electric signal group, we can create A plus, A minus, B plus, and B minus. For do this, we need the pneumatic component like double acting cylinder. In fluid sim, we can find for the icon is like this, and for the hardware, double acting cylinder is like this picture. And the second one is electric control limit. Electric control limit is like switch limit that we can use in pneumatic system. For the icon in simulation, we can use this icon is like ruler like this, and the real hardware is like limit switch. And the third is electric valve. This is the valve that active with electricity. We can control with electric power, so the valve can active and on and off with electric. And the fourth and is switchboard. We need the switchboard and also the relay board. For the control signal, we already decided before that we will make a control signal from A plus, and then move to A minus, and B plus, and B minus. So this control signal is related with the cylinder's position. When the A plus, A minus, and B plus, and B minus. To activate this cylinder to be in this position, we can we will start with start button. This line or this side is for input, and the output is cylinder position. So when we push the start button, the cylinder will be active and move to A plus position. When the A plus position is reached, the limit switch A1 is active. After that, when the limit switch A1 is active, so the cylinder should be moved to A minus position. After the A minus position is reached, the limit switch A0 is active. And then when the limit switch A0 is active, it will make the cylinder B to move in B plus position. When cylinder B is on B plus position, the limit switch B1 will be active. If the limits if the limit switch B1 is active, it will trigger cylinder B to back to the B minus position. When B minus position is reached, it will activate the B0. This is the control signal scenario that we will make in the simulation. after we draw this uh, simulation, we need to divide this control signal on a group. We can see that in this position we have a plus and a minus, so we need to separate with we should divide in the different group. So, and a minus and b plus we can put it in the one group, and b plus and b minus should be separated. Okay, we can draw like this. For this side we can call it with group 1, and a plus and a minus and b plus we can put in the group 2, and also and b minus in the group 3. So after we draw this signal, we can move to design the diagram in a fluid sim. So we need to draw for the cylinder and the valve. We need to cylinder A and cylinder B, and we need to for limit switch. Start with A0, A1, B0, and B1. And the last, we need two electric valve that has two control signal, Y1 and Y2 for cylinder A, and Y3 and Y4 for cylinder B. As a cascade control, we can make the diagram like this. So we need power with 24 volt, and in the first line we can draw with the start button and normally close relay K2, and we can put relay K1 here. And for this diagram is a latching system for lock the condition if this line is already active. So K1 is active and this relay will be closed, and after that the position or the condition will be locked. So the active line will be always active like this. Okay, this line can be turned off with activate relay K2, because we have normally close relay K2. If relay K2 active, so this switch will be open and this line will be open circuit. Okay, same with this for the K2 here, or or this line, we also have a latching system here, and after that we can put the diagram for the group 1, group 2, and group 3. For the next, we can make the diagram or schematic in a fluid sim. We need to know how to make the schematic for this condition. with start button, limit switch, and this is for the cylinder position. And we will start we will start with open the fluid sim. We will start open to fluid sim and try to draw this schematic and making simulation. We already open the fluid sim here, and for the first we should prepare the double acting cylinder. This is for the cylinder A and cylinder B. We can put here, and we need a delay. We should valve. Where is the valve? One way flow valve here. We can rotate. And we can make a copy to make a delay. And then we need to 5 two-way valve here. We can use we can use this. And we can make a connection for each component like this. And we need to put a ruler or a limit switch here. This is for A0, the begin is 00, and A1, the begin is 100 and 100. Like this. And for the second is for B0, 00, and B1, 100, 100. So this we need to put air compressor, and we connect it with number 1 node to the valve. For the valve we need to configure electrically valve. Like this. And we need to choose electrical. And for the pneumatic diagram we already done, and we need to draw electric part. So we need to put the power is 24 volt and 0, and we can draw like the presentation slide. We need to put push button. We can put push button here. This is the start button. We can write start. Start is here. After that we need put a close loop switch. This switch is B 0. Okay, this switch is B0, and we need to put switch after that the relay, K1 relay. Okay, this one is K1 relay, and we also need the K2 relay here, K2. Okay, we can connect it first. We can make connection with each other like this. Okay, and this switch we need to change with the, this one is K2. So if the K2 relay is active, so this switch it will active. And for this we need to change, because we need to change with normally close switch. Okay, like this. Okay. This one is K2. So when for this line, it will be active, this line, when we push the start button. So after this active, the relay K1 will be active. For lock this state, we need a latching system, so we need to put the switch, or normally open switch, and we can connect it with K1 like this. Okay, we connect it here and here. So when this line is closed loop, closed circuit, when this line is closed circuit or active, so the relay K1 will be active, and this switch will close. If this switch is closed, we have two line is active now while we press the start button. But if we release the start button, the this line will still active. Okay, this line is still active. And for the second part is we need to prepare switch for activate K2 relay switch, and then K2 relay we will use for activate the group number 2. So we need to make a connection, this one, and this switch we will connect it with A1 switch, limit switch. Okay, after that we need to put close the switch is B1. Okay, we can connect it to this one. Okay, yeah, after this we need to put the latching system here with K2, and then like this. Okay, like here. And we can draw the next line. The next line we start with K1, K1 switch, here, and this line is connected with group 1, group 1, so we can put the relay valve solenoid here, which is this is Y1, so we need to put the name. This is Y1, and this one is Y2, and for this one is Y3, and the last one is Y4. Okay, and for this valve relay we can put the Y1. Okay, when the start button is pressed, so the K1 will be active. It will make K1 switch here is closed, so it can make the Y1 active. If the Y1 valve is active, the air pressure will flow to this line. Okay, so it can make the cylinder move from A0 to A1. After the cylinder reach A1 position, we need activate the Y2, so we can draw the next line with start with switch K2 here, so the K2 will activate the Y2, and Y2 here, we can put Y2 here, Y2, and it can be connected here with this. Okay, so if the cylinder or has reached in A1, so the limit switch A1 is active. It will make this line is active, and then K2 is active, and this switch is, we can put K2 will be active, so the Y2 is active. Okay, after the Y2 is active, the cylinder A will be moved back to A0. Okay, to A0. So when the cylinder already in A0 position, Y3 valve should be active, so we can put the switch here. That switch, it will sense the cylinder A position. So if the cylinder A position already in A0 position, the Y3 valve should be active. Okay, so for this switch we can set as A0. Okay, A0. Y3 cylinder can be active if the limit switch A0 if the cylinder A is in A0 position. Okay, after Y3 active, the cylinder B will be moved to from B0 position to B1 position. Okay, B1 position. and we can set the last line with the open close loop close normally close relay switch, normally close switch. This one is K1 and this one is K2. Okay, okay, and we can put Y4 here. So when the Y3 is active now, it will make uh, the cylinder B is in B1 position. So B1 position, so in this switch will be open. If this switch is open, K2 will be inactive. Okay, if K2 will be inactive, so this switch will be off or open, and the active line will run to the line number 9. Okay, so the relay K1 and K2 is not active, so it will make the valve Y4 is active. If Y4 valve is active, the cylinder B will be moved to B0 position. Okay, we can try this simulation with press the play button, or if you want to step by step process this simulation, you can click the single step button. Okay, we can try with single step button so we can know how this simulation works. Okay, put yes. Now for the first, the line 9 is active now. This is the starting position. If we press the start button, so the line number 1 will be active. Okay, will be active, and relay K1 is active now. Relay K1 is active now, so it make the normally open K1 switch will be closed. Like this. If the normally open relay K1 is closed, it make Y1 active now. Okay, if Y1 is active, the cylinder A will be moved from A0 position to A1. It means it will reach A plus position. Okay, we can see this air flow to the cylinder A and make cylinder A work to the A1 position. Okay, after cylinder A reach A plus position or A1 position, so the limit switch A1 is active now. If limit switch A1 is active now, so the line 3 will active, and it make K1 it make relay K2 active. If relay K2 active, this normally close switch K2 will be open, so it will make with open circuit for the line number 2. Okay, The line number 2 is open now, and K2 active, so the switch K2 close and switch K1 will open. So if this switch K1 is open, valve Y1 will be off. Okay, after this the line 6 will active and Y2 will active, so make the cylinder A move back to a 0 position. Okay, can click. Okay, if cylinder A is already in a minus position, it will make a 0 limit switch will be on. If a 0 limit switch is on, so this line will active a Y3 valve. Okay, if Y3 valve, it will active now and make the cylinder B move to B plus position. Okay, if cylinder B already in B plus position, it makes B1 limit switch is active. If limit switch B1 is active, this switch will make line 3 in open circuit, so the relay K2 is inactive now. Okay, if relay K1 is inactive and relay K2 is inactive, so this switch or this line 9 will active now, and it makes Y4 active. If Y4 active, the cylinder B will move to B0. Okay, you can see the cylinder B will move to B0 position, and the simulation is done, or the process is done. The cylinder A start from a 0 position to the A plus, A minus, and B plus and B minus. We can see with the play button here. When we start, okay, so we can set the delay, maybe delay with 70%, so we can see the movement. This one 70. Okay, we can stop and play with start button like that. This is the full simulation of our scenario. I hope you can understand that I have explained and how to make the simulation with Fluid Sim. Thank you very much. We already wiring for the Penumatic, and this is the diagram from the sample. And for the electrical relay is the Penumatic, and this system will work A plus. This is the A piston, A plus, and then I minus. After that, the second piston will be moved to B plus and move again to B minus. So we want to try
from this is a button, push button, and the relay. You can use this relay and this button. For the first, after we turn on the electricity box, and we can push this button, and the piston number 1 will be moved. Before that, we should open the pressure to make sure the pneumatic will be works, and then we can push the piston 1 move to the A plus, after that move to A minus, and after the piston reach the I minus, the piston 2 works, move to B plus, and then B minus. This is the system of